Now, in the earlier lecture, we have already learned in detail about the various kind of imposed action. Now, in this lecture, we shall restrict our discussion to three important, we can say, different kinds of the imposed actions. One is when, when we have to deal with these kind of systems where we know that we have to install a crane on the top of that. So 5T means that the lifting capacity here is 5 metric ton, or we can say 5000 kg, and it is installed onto the, we can say, gantry girder. So this girder here, this is known as the gantry girder. That is Gantry, gantry girder. And this girder, the one that is basically the part of the crane itself, that this is known as the crane girder. So the when the crane moves on the top of this gantry girder, there are these various load that comes onto this particular gantry girder. One is the obviously the vertical load. Let us say this is the gantry girder cross section. So one is the vertical load, another one is the horizontal load, and one is the, we can say, the longitudinal load that comes along the length of the girder. So this obviously, when because of the self weight also, and let us suppose it is lifting the 5000 kg load over here. So for that, half of the load shall be transmitted onto this particular support, and half of the support shall be transmitted on the other perpendicular support. The horizontal lateral load is when the, we can say, because of the movement or because of the minor adjustment or because of the nature of the like load itself, some percentage of the load is transmitted horizontally also, and it may happen that at the time of the movement there may be we can say acceleration, or there may be a braking force also. So because of that, there shall be a longitudinal force also on the girder. This is also another example, and this is the picture of the SpaceX itself, the one that is owned by the Elon Musk. So in here, you can see that how the structural arrangement has been done. So this is basically the portal. These are the portal frames that are, we can say, supporting the structure itself. And these are known as the girds. The horizontal one that support the sheeting, these are known as the girds, and these are the purlins. So purlins are basically the one that supports the sheeting on the roof. So both of them are serving the same purpose, but their name is different. Just to classify, that is the walls, the side sheeting on the wall, that is basically the gird, and the sheeting on the top, that is basically the, we can say, purlins. And in here you can see the these also. So these are the services. Either these are the ducts, or either these are the, we can say, the requirements of the like project itself, where we may have to do the ventilation or the centrally air conditioning. So that is basically the, this particular, we can see these as the ducts. But coming back to the topic here, this is basically the we can say gantry girder, and this is basically the crane girder. So here you can see that how after how this is basically supported with the help of, usually this is supported with the help of the cantilever beams that are coming from this particular portal arrangement. Similarly, this is also another excellent picture where we can see different number of cranes and different types of the crane girders also. So usually, these stiffeners are provided because there is this localized shear force. So that is the basic standard that is usually applicable for all the, structures. And this is basically the, we can say, the building column. And on top of that, this is the portal that is coming from one end to the another. So this is basically the, we can say, gantry girder, and this is like the standard practice as per my experience also. So what I usually do is that I do provide these stiffeners here, and these stiffeners are serving the purpose that the crane load that is basically acting onto the various along the cross section as a point load itself. So it is necessary that the shear localized shear forces or the localized shear strength that should be sufficient. So that is why it is always recommended to add these stiffeners here after, like it is usually after added 450 mm or 600 mm spacing, and these are usually 6 mm stiffeners, 6 mm to 8 mm stiffeners. So coming back to the discussion, this is the basically the, we can say, gantry girder. This is the crane girder, and one column is also supporting this gantry girder on this side, and this is also another secondary girder, which is basically for this particular crane here. The same is the picture for here also. So in here, we can see here that this is basically a four-wheel crane. That is, if we are watching this from the upper view here, so it shall be basically supported onto the, we can say, four wheels. So two wheels on one side and two wheels on the another side. And that is the basic concept of the, we can say, crane rails. So section 3.7.3 help us deciding the horizontal actions on the crane rails. Vertical action, obviously, that shall be, as per the capacity itself and the self weight of the crane girder itself. And usually, if we are purchasing the crane, usually they do give us a data sheet of what exactly are the vertical load, what exactly are the longitudinal load, and what exactly are the lateral loads. Still, if the vendor is not providing those loading, we can take the help of the code itself, and according to that we can decide the loading percentage of the loadings. So transfers to the rails and parallel to rails. So for transfers to rails, for electric overhead cranes, it is 0.2%, and for hand operated cranes, it is 0.05%. So horizontal imposed acting transfers to crane rail shall be taken as a static wheel load resulting from the combined weight of the crab and the load lifted multiplied by the following factors. So electric operated crane, that is also named as EOT, and hand operated crane, that is also known as the HOT. So electric operated traveler cranes, hand operated traveler cranes. So for electric operated cranes, it is 0.2. For hand operated, it is 0.05. So this is basically transfers to rail, that is along this direction. And for parallel to rails, that is along this particular direction. For EOT, it is basically 0.1, and for hand operated, it is 0.05. Nowadays, in most of the structures, EOT is only used. So what we can do is that, let us suppose the figure that we have is 10 metric ton, or we can say 10,000 kg. So we can say that basically 0.2 multiplied with 10, that is 2 metric ton, 10 shall be acting along this direction, and 1 metric ton shall be acting along the other, that is longitudinal direction itself. Or in kilonewton, if we are talking about, let us say 100 kN is the like number that we are talking about. So this comes out to be 20, we can say, kilonewton, and this comes out to be 10 kilonewton. And usually the scenario is that, if we are talking about these, we can say, gantry girders, they are usually anchored also on the top. What I'm trying to convey here is that, let us say this is this particular column. On top of that, we are basically making this particular seating arrangement. On the top of that, we are fixing the this gantry girder. So that is basically, a connection is also made here as to support this particular beam horizontally, so that we don't have any, we can say, instability because of the rotation of this particular gantry girder. After that, the second discussion concept was regarding the grandstands. So if we are watching the, let us say, design of the grandstands, let us say if you're talking about the Melbourne cricket ground, MCG, or if we're talking about the Gaba cricket stadium. So you must be, as an engineer, we are always wondering how exactly the case, let us say this is the scenario here. So in this particular case, the whole structure is fully loaded. So if this whole structure is fully loaded, then we can say that then we can only understand how much stresses must be there in this particular structure, and this is designed for that only. So here you can see that thousand, or we can say tens of thousands of persons are sitting in this particular stadium. So there must be a separate guideline for the grandstands also. So for that, the AS1170.1 help us in providing the guideline for the grandstands. So grandstand stadium assembly platform reviewing stand shall be designed to withstand horizontal imposed action in addition to the imposed action given in clause 3.4. So this we already studied in the earlier, but horizontal actions must also be there. So for platform with seats, the following separate load case, not applied simultaneously at each floor level, at each row of seats must be applied. It is 350 Newton per linear meter for, we can say, seating arrangement along the line of the seat, and 150 Newton per linear meter for seating perpendicular to the line of seats. And for platform without seat, 250 Newton per meter square of the plan area, that is 0.25 kPa. So this imposed action clause need not be applied simultaneously to the required earthquake action. So this is just, we can say, a horizontal imperfection or a horizontal load that may be, obviously, if we are talking about a structure, something like this, then obviously it is not only the vertical load. We are talking about the horizontal load also. So that may be due to the nationality, or that may be due to the eccentricity of the, we can say, the seating arrangement, or due to the human behaviors. So that is the, basic criteria when we are talking about the design of the cricket stadiums. Now, usually, uh, in the terms of the structural engineering language, I shall say, most of the times these are known as the bleachers, Bleachers. So what we usually do is that we do install the seating arrangement as a precast members. So they are usually, casted something like this, or approximately, we can say, 4 meter length or 5 meter length, and they are basically lifted and installed on the required location. So that is the, the basic thing for, if we are talking about the design of the precast, and that is also designed for the loading arrangement required. So that loading is usually in the range of 400 to 500 kg per meter square. In addition to that, we have to apply the transverse loading as per the clause, the one that we have discussed, that is 3.9 for grandstands. So that is clear. And after that, the third scenario, that is although not important, I can say, but let us say if we are, having a project on the countryside where we have to design the structures for the animals. Now, this Mrs. Chick, we can say, must not be putting a very high quantity of load. But still here, we can see that how beautifully we can also say that, or how engineering wise that is also like very good. The member is also like quite good here. Thus, that is also tied in the other direction also. A small bracing is also applied, or a small steps are there, and steps are also serving as the bracing. Here also we can see that how, this is like also quite good, where when we're talking about the structural engineering, the truss arrangement is also like quite strong, and on top of that, the connection is also looking quite good. So what I'm trying to convey here is that farm structures can also be like designed, and the AS1170 also help us in deciding the live load for which it needs to be designed. So for farm structures, we can say that, let us say if we are, supporting the pigs up to 225 kg. So for that 3.5 kPa load shall be applied. For, we can say, poultry farmhouses, 1 kN per meter square has to be applied. For horses, the loading is 5 kPa. That is when we are talking about the heavy vehicles on the upper, like in the previous lecture. We were discussing that for vehicles up to 10,000 kg, 5 kN per meter square load has to be applied. So for horses also 5 kN per meter square load has to be applied. So this is how, you can understand. But, in majority of the structures, it is usually that horses are stored on the, or, kept on the ground floor level itself. They are not kept on the upper floor. Similarly, when we're talking about the poultry, it is most of the times it is the case where they are kept on the upper floors also. For sheep also, it may be a case where they're kept on the upper floors, but in pigs also, it may be a case where they're kept on the upper floors. But horses, that is very rare. And for farm machinery also, like it is usually supported on the ground floor level itself. So considering that, you can see that this is basically the guideline for farm buildings as per the AS1170.1. So I hope the concept is now clear to you, that how you can calculate and apply the imposed actions, the lateral imposed actions, the grandstands, the EOT crane structures or gantry, the baluster, the glass design, the handrail design, the parking structures, and different kinds of trust, different kinds of roofing arrangement, and we can say different occupancies like restaurants, warehouses. So I hope this series of permanent and imposed actions, although that is quite ignored when we are dealing, because it is assumed as very easy, but that also becomes a very important part when we are dealing with the overall optimization or value engineering, where when we are trying to construct a safe as well as economical structure. So it is very important that we do need to understand the how the loading behaves, or what exactly are the guidelines as per AS 1170.1 for permanent and imposed actions.